Okay, Geometry Chapter 7, Section 2. Last time we met, we went over proportions, or ratios that equal each other, and we used the cross products to do some solutions. We are going to use that technique and now apply it back to geometry. And we are going to be looking at the definition of similar polygons. You have already learned what congruent polygons mean. Remember, congruent polygons have all corresponding parts of congruent, and often we have triangles are congruent, but all polygons have that fact if they are congruent. All corresponding parts are congruent. All corresponding sides are the same length. All corresponding angles are the same measure. Similar is a little bit different. When congruent polygons are drawn, we know that they are exactly the same size and shape. So if I want a congruent polygon to this nice six-sided figure called a hexagon, then we are going to have something that is going to be exactly the same size and same shape. So there we have two congruent hexagons. Every corresponding side is the same. This one happens to be regular, actually, and they're all the same. Every corresponding angle is the same. Similar triangles are the same shape, but not necessarily the same size. So instead of having two congruent hexagons up here, I could have two similar hexagons. So they have the same shape to them, but their sizes are different. That's the everyday definition of what similar means. If we have two similar polygons of any shape, their corresponding angles are going to be congruent. So that is just like the congruent ones. So whatever angle in one matches in the other, those are exactly the same size. Whatever angle in one corresponds to the other, those are exactly the same size, etc. But their corresponding sides, the corresponding side lengths, are proportional to each other. So these sides are not the same length, but they do have the same proportion. If this is 2 and this is 1, this is 4 would mean this would have to be 2. 2 to 4 is the same ratio. 2 to 4 is the same ratio as 1 to 2, or they are proportional to each other. So in similar polygons, the corresponding angles are congruent, same measure, but the corresponding sides are proportional. So here we have an example for us. We have polygon ABCD right over here. Here we have polygon ABCD. It is similar. Notice the symbol right there. On the congruent symbol, I drew the congruent symbol just a minute ago. The congruent symbol, we have an equal sign with that squiggly line. Well, if I am just similar, we just have the squiggly line. It is not equal in all aspects. So ABCD is similar to WXYZ. It means the corresponding angles, A and W correspond. They're in the same order over here, and they are the corresponding angles that are congruent. So just like when we learned how to write congruent statement, the order of the letters is important. The B is the second letter, the X is the second letter. That means the B and the X are corresponding angles. They are congruent to each other, etc., all the way around. Corresponding sides are not congruent. They are just proportional. So let me pick corresponding sides. If I went between A and B, W and X must correspond. A and B is 15. W and X, they correspond. So AB is to WX. 15 to 5 is going to be the same. They went BC, the next two letters. BC is 12. BC is 12. 2. Second two letters are XY. XY, 4. 12 to 4. 15 to 5 should equal 12 to 4. They are the same proportion. We could reduce these. If I take 15 over 5, 5 goes into both of them. 5 goes into 15 3 times. 5 goes into 5 once. It reduces 3 to 1. If I took the 12 to 4, 4 goes into both of them. 4 goes into 12 3 times. 4 goes into itself 1 time. 3 to 1, or in the ratio of 3 to 1. They are proportional. They have the same ratio with each other. Similarities right down here. They are emphasizing the fact that the order is important with those letters. So the vertices that match up, F and J, both red in this one, they are the first letters. The first letters, F and J, are the ones that correspond. Angle F and angle J are the same angle measure. G and K correspond. Angle G and angle K are the same measure. H and L correspond. Angle H and angle L are the same measure. So our order is important. And then we can match up the sides. So there they wrote all the congruent angles that I just marked. And then the sides. FG over JK. FG, that's going between the angles that I marked with 1 symbol and the one I marked with 2. So between 1 symbol and the one I marked with 2 must be the ones that match over here. So FG and JK match up with each other. FG and JK match up with each other. So the order again is going to help us keep track of which ones correspond. So let's try it out down here. It says in the diagram, NPQR is similar to UVST. List all pairs of congruent angles and write a proportion that relates the corresponding size. So let's work on the corresponding congruent angles. Angle N must be, said the right thing, wrote the wrong thing. Angle N must correspond to angle U. It is congruent to angle U. So list all pairs of congruent angles. There's one. The next one, angle P. Angle P must be congruent to angle V. They match up. Angle Q is the next one, must be congruent to angle S. And finally, angle R must be congruent to angle T. Those are all the angles that match up and are congruent to each other. Corresponding sides, I'm going to take the first two. So I know NP must be similar to, what's the first one? UV and UV. Now, it would be true to say NP is proportional with UV. The lengths, I should take away that little segment symbol. The lengths are proportional to each other. So write a proportion that relates them. Equals, if I take the next two, which would be PQ and VS, PQ to VS, which will equal the next two, QR and ST. QR to ST, which will equal, and then I can do the last one and the first one, RN. RN, last one and the first one, TU. So there we have all our corresponding angles, and all the sides are proportional to each other. Scale factor. The scale factor is the proportion or the ratio of the corresponding sides once it is reduced. So they say here that in the diagram, triangle ABC is similar to triangle XYZ. Have to keep the letters correct. The scale factor of ABC to XYZ, 6 to 3. Notice those are the corresponding sides, but 6 to 3 is not reduced. 6 to 3, 3 goes into 6 2 times, 3 goes into itself once, 2 to 1 is the scale factor. Or I could say 2 to 1, written as a fraction. If they wanted the other order, notice this is triangle ABC to XYZ, so I went left to right, 6 to 3. But if they wanted the other order, if they say XYZ to ABC, XYZ to ABC is 3 to 6, or 3 to 6. Reduces 1 to 2. 1 to 2 is the other scale factor. The scale factor, the order is important. Notice that first one they just said 2, the number 2, that is the same as 2 over 1 or 2 to 1. But if we have to do math with it, just the number 2 by itself isn't real useful, but 2 to 1 is going to be useful. So the order and the scale factor makes it different. It's either 2 to 1 or it's 1 to 2, depending on which way they ask. Make sure you answer whichever way they ask. Determine whether the triangles shown are similar or not. Well, if they are going to be similar, there are 2 things I have to check. Number 1, I have to check the angles. All the corresponding angles have to be congruent to each other. So let's try it out. I have an angle N that's congruent to an angle R. I have an angle Q that is congruent to an angle S. They didn't say anything about angle P down here and angle T. But some of you may remember the third angle theorem. If 2 angles in one triangle are congruent to 2 angles in another triangle, the third angles must be congruent. And they must be congruent because any triangle, the interior angle sum is 180. Both of them has to add to 180. 2 of the angles are the same, the third must be the same as well. So I have checked condition number 1. That doesn't mean they're similar yet, though. That just means my corresponding angles are congruent. Condition number 2 is all the corresponding sides must be proportional. Now I want to write a potential similarity statement in triangle NQP. If I go in that order, NQP, we are going to see if it's similar. But if it is similar, the order, I'm going to remove the similar for a minute because we don't know, the order would have to be RST, RST, so that I can keep straight the proportional sides that I am going to be checking. That's my second check. I need to have proportional sides. So let's do some numbers out here. If I do N to Q, my first ones, that's 12.5, over, it would be R to S, which is 10. We are going to see, does it really equal? Let's do another one. Let's do a QP, 11.5, which would have to correspond with ST, 9.2. So there's our question. And then there's one more that also will have to be true. This 15 is going to have to correspond to that 12 in the second one. So are these things really all proportional to each other? Well, there's 2 ways of checking. One way is to do cross products. And I'm going to start by doing some cross products. I'm going to multiply these 2 together, and I'm going to multiply these 2 together, and we're going to see if those cross products equal each other. If we did 12.5 times 9.2, you can run your calculators and get them going. 12.5 times 9.2, your answer, 115. So I got 115 when I did that. Now I'm going to go 10 times 11.5. Well, that's a little easier. I know that's 115. Well, that tells me that these 2 are proportional. This one is good. I don't know about the second one yet. I'll change colors here. I'm going to take this cross product. Now, this cross product doesn't have to equal 115. It just needs to be the same among these 2 ratios. So 11.5 times 12, so on your calculators, 11.5 times 12, you can see if you're faster than me, 138. Then I'm going to go 9.2 times 15. 9.2 times 15, I get 138. Those cross products are equal, so this one is true. Second condition, all the sides are proportional. So one way of checking that is to do the cross products to see if each pair, this pair I needed to get the same, this pair I needed to get the same, not all of them, but just in the pairs, do I get the same cross product solution? And we do. A second way of checking it is you could divide. You could take this and divide it. 12.5 divided by 10, that would be 1.25. Now I need to divide this. It needs to be the same. 11.5 divided by 9.2, 1.25. That one also 1.25. This one, now all three of these will have to be the same. 15 divided by 12 equals 1.25. So if you do a division of each of those ratios and you get the exact same answer, that is another way of checking, yeah, those ratios are all the same. They are proportional to each other. They are similar to each other. So it says write a similarity statement and scale factor. So if I want a scale factor, I need to take two corresponding sides and reduce it. Now there appears to be an easier one to reduce right there. I have some nice integers. I'm going to take that 15 over 12 and reduce it. Well, 3 goes into 15 5 times, 3 goes into 12 4 times, 5 to 4. Scale factor, I'm going to call it SF, equals 5 to 4. So I have found the scale factor between them, going left to right. If I went the other way around, it would be 4 to 5. But I wrote it in the order of left to right. Explain your reasoning. The reasoning would be the corresponding angles are congruent and the corresponding sides are proportional. That would be our reason. We'll get to some where we write the reason down. Let's try it down here. It says find the value of each variable if these two triangles are similar to each other. So we know that JLM on the left is similar to QST on the right. So I know they are proportional. So I can take and find two sides where I know the values between 1 and 2 of the angle marks. Between 1 and 2 of the angle marks. Those are the ones that correspond. JM and QT. JM, the first and last here, QT, the first and last, those are the ones that correspond. I am actually going to start by getting the scale factor, 4 to 2, 4 to 2, or that reduces 2 to 1, which can be written as the fraction 2 to 1. I am going to use the scale factor to help me get what x is and what y is. So if I want to get my x, well, here's x. 6x minus 3. 6x minus 3. What does it correspond to? Well, it's between M and L. So between M and L is T and S. We have to find the one that matches. So 6x minus 3 corresponds to 3. And it must be in the ratio of 2 to 1. Because that's what the scale factor is between them when I go left to right. Make sure you keep going the same order. Remember, our scale factor can be different depending on the order. So now I can find my cross products. 6x minus 3 times 1 equals 3 times 2. So 6x minus 3 equals 6. 6x equals 9. X must equal 9 over 6, which reduces to 3 over 2. X is 3 over 2. If I'm going to solve for my y, I need to find something with y in it. There we go. 3y minus 2. I need to know what it corresponds to. It's between L and J. So if I come over here, L and J, or J and L, so Q and S. Q and S. So it corresponds to 5. It also must be in the ratio of 2 to 1. That's my scale factor. Cross products, 3y minus 2 times 1 equals 5 times 2. So 3y minus 2 equals 10. Add my 2, 3y equals 12. Divide by my 3, y must be 4. Moving on. Try it again. Moving on. There we go. Perimeters of similar polygons. We know that we find the perimeter by adding all the sides. AB plus BC plus CD plus DA, right here. AB plus, they wrote it all out, adding all the sides. If I want the perimeter of the other one, JK plus KL plus LM plus MJ, they added all the sides. So right here they have said that the ratio of the perimeters equals the ratio of any two corresponding sides. If I just took AB to JK, that's the same ratio as the perimeter ratio. So whatever the scale factor is between any two similar polygons, that's the same as the ratio of the perimeters. So I don't have to find always all the different pieces to figure out what the perimeter is if I know the ratio. So let's try it out here. If MNPQ, so the one on the right, MNPQ, is similar to XYZW, the one on the left, so they happen to be going in this order, right to left. Find the scale factor of MNPQ to XYZW. So the scale factor, and again, I'm going right to left to make sure I keep that same order. So I need to find two that I know match. Well, there's only one thing I know on the left side. So the WX goes with the Q and M, with the 8. The W and the X, they're the first and the last. The M and the Q and the M. So if I do the scale factor, it will be 8 to 4, going right to left. Scale factor, 8 to 4, reduces 2 to 1. There's the scale factor, 2 to 1. Not 1 to 2, because that would be the other order. And they want to know what is the perimeter of each polygon. Well, I could figure out the perimeter of this one right over here just by adding it up. So I know MNPQ is going to have a perimeter of 10 plus 7 plus 8 plus 9. So get your brains, add those all together, beat me to the answer. I don't know if you did or not. 34. So the scale factor is 2 to 1. That happens to be the same ratio as the ratio of the perimeters. One perimeter is 34. The other perimeter, I'm going to call it P. I don't need to figure out each of the individual missing sides. I can just do this proportion. So let's try it out. 2 times P must equal 1 times 34. Divide by my 2, 17. There it is. The perimeter of XYZW. XYZW has a perimeter of 17. And the first one, what did it have? A perimeter of 34. You could figure out each of the missing pieces in the first one and add them together, but there's the shortcut. We don't need to because we have that theorem. All right, get your paper out and let's do some problems from the book, page 472. 472. If you need to stop the video until everybody is ready, that would work. Page 472, maybe everybody's all ready. Number 1, 472. Says list all pairs of congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons. So number 1, they have said triangle ABC is similar to triangle XYZ. So all we are doing is we are matching up the angles. So I know angle A is going to have to be congruent to angle Z. I know angle B and angle Y. Angle B congruent to angle Y. I know that angle C and angle X. Angle C must be congruent to angle X. They want us to write the proportion that relates the corresponding sides. So if I start with AB, it would match up with our ZY. It would be the same as if I went to BC, the next 2 letters, YX, the next 2 letters. The last and the first, CA, you could say AC. CA and XZ. They're the corresponding sides. That would be in proportion to each other. Number 2, we have quadrilaterals here. So I can start with my angles. First one, angle J, angle T. Angle J corresponds to angle T. Second one, K and S. Angle K congruent to angle S. Third one, L and R. Angle L corresponds to angle R. And the last one, M and Q. Angle M corresponds to angle Q. Same thing with my side. So JK, TS. JK, oh, that's funny. TS, some of you will get that. KL, SR, KL, SR. Now the sub knows how good the jokes are in this class. LM, RQ, LM, RQ. We're just taking each pair as we go along. One more pair, the last and the first. So MJ and QT. MJ, QT, sides proportional. Number 3. Determine whether each pair of figures is similar. If so, write the similarity statement and scale factor. If not, explain your reasoning. So remember, there are two things to check. Check number 1 need to be the angles. We need to see if the corresponding angles are congruent. So as you look at those, well, they have 3 right angles. We know the last one must be a right angle because the quadrilaterals both add up to 360 degrees. So we've used 3 90s. That's 270 in each one. We still have 90 degrees left over. So we know that the angles make it. So check on the angles. Proportional sides. That's the next thing we need to figure out. Are the sides really proportional? So let me start with the 4. 4 would have to correspond according to the shape. Well, it would have to match up with the 9 over there. So is it really proportional with the 10 and the 18? Well, this will be pretty easy to do cross products. So if I did 4 times 18, if I did 9 times 10, what's our conclusion? I hope there was a resounding no. Those are not similar. And what's our reason? How do we know these are not similar? Because the sides not proportional. We had corresponding sides that were not proportional right there. Didn't work. So notice the angles were good, but the proportional sides were not, therefore they're not similar figures. Number 4. Let's see, let's try it out. Let's look at the angles again. So 2 checks again. I'm going to see the angles. Does it work out or not? 27, 27, 36, 36, 117, 117. We're happy with that. We are going to check the sides. Am I getting proportional sides? So I'm going to start with the smallest number, 6, in the first one. That will have to correspond to the smallest number in the second one, if they are going to be similar. So the 6 in the left one would have to match up with the 3 in the right one. Is that equal? We'll see. I'm going to go to the next largest number, 8. 8 in the left would have to match up with 4 in the right. The next number, the biggest number, is 12. In the left, biggest number in the right is 6. So the 12 and the 6 would have to match. So I'm going to take division on this one. 6 divided by 3, that's 2. 8 divided by 4, that's 2. 12 divided by 6, that's 2. Every single one of those are in the same ratio, so they are similar. They are proportional. So that one checks out as well. So I can say yes, those are, and the reason, corresponding angles congruent and corresponding sides proportional. Both of those, again, have to be true if we are going to have similar figures. And we did. We had similar figures. Number 5. Each pair of polygons is similar. Find the value of x. Start out with this idea of scale factor. let's figure out what the scale factor is. I'm going to go left to right. So on the left side and the right, if I'm looking for a number that corresponds where I know the value of the sides on both of them, the 4 and the 8 are the ones that match up. So if I'm going left to right, it's 4 to 8, which reduces 1 to 2. There's my scale factor. So I can now use that scale factor and know that any other corresponding sides have to be in that same ratio. So 1 to 2, if I go left to right, 3 matches with the x. 3 to x. 1 times x is x. 2 times 3. 2 times 3 is commonly referred to as 6. I know the value of x. Now I know some of you about 60 seconds ago said, oh, x is 6. Well, sure. You can see this one probably pretty easily without doing the math. Make sure you write the work, do the math, because we get into more involved ones and we need to practice on the ones that maybe you can see without doing the math. Maybe you can't, but you need to make sure you do the work so when we get to the more challenging, we know how to do the work. Number 6, same thing. I'm going to take the same process. This process will always work for you. I'm going to figure out the scale factor. I'm going to go left to right again. I'm going to find 2 sides that correspond. They already told us they were similar. So I noticed that the 8 on top should match up with the 2 on top, and you could pick some others. 8 to 2. So if I did 8 to 2, that's 4 to 1. So I know 4 to 1 is the ratio from left to right. So anything else has to be proportional to it. So x is on the left. It would have to match up with the 4 on the right. X to 4 going left to right. 1 times x is x. 4 must equal 4 times 4. 4 times 4 is 16. There's the value that x must be in the second one. Number 7. Design a blueprint. Actually blue, which is why they're called blueprints, though usually they were opposite that, white background with blue ink, but anyway. Number 7. On the blueprint of the apartment shown, the balcony measures 1 inch wide by 1.75 inches long. So pretty small balcony, but maybe you can fit. If the actual length of the balcony is 7 feet, what is the perimeter of that balcony? All right, we know there's a scale factor going on between the drawing and real life. So let's work on that. Let's figure out the scale factor between the drawing and real life. Same idea as those last 2 problems we were doing. So they tell us the dimensions. It's 1 inch wide, 1.7 inches long, and then they tell us the actual length is 7. So I can compare the lengths and the lengths. So our drawing is 1.75. Our actual is 7. So that's going to be the scale factor of them. Now, if I was really asked to write the scale factor, we would get rid of that decimal. But all we are wanting to do is use this scale factor. So I'm going to leave it as 1.75 to 7. In a minute, I'll show you how to get rid of that. Equals, now remember, this is drawing to real life. And this drawing happens to be in inches, and real life happens to be in feet, but that's okay. The scale factor doesn't have to be in the same units. They want to know the perimeter. Well, I need to do the perimeter of my drawing on top to the perimeter of the actual balcony. Well, I can figure out the perimeter of that drawing. That balcony here was 1 by 1.75. Well, I've got 2 1.75s, and I have 2 1s, and so if I got the perimeter of that drawing, think a minute, see if you can get it faster than I can get it. Anybody have it? I have to do it. 1.75 times 2 plus 2 more. What do I have? 5.5. 5.5. There's the perimeter. So my perimeter of the drawing was 5.5. The perimeter ratio must be the same as our scale factor ratio. So I'm going to do my cross products. 1.75 times P will equal 7 times 5.5. I can get rid of this 1.75 by dividing. Divided by 1.75 eliminates it there. The perimeter of the actual porch must be, go to your calculators, 7 times 5.5 divided by 1.75, 22. And the units, the real porch was measured in feet. So we know the perimeter of the real porch is 22 feet. Page 472. Numbers 1 through 24, 27 through 30, 35, 36, 40 through 45.